Hey everybody, welcome back. Glad you're with us. We're looking at example, well, in the notes it says example 4 or 5. It's actually 5 because you guys know we're in chapter 5, but it's example 5 of the notes. And we did example 6 today in class. That was the one where we had the dolphin jumping up to get the ball that was being dropped by the dolphin trainer. But this is the one that's actually right before that. So you should have two different panes or two different slides to write in, and I suggest you do part A in one and part B in the other. That's what I'm going to do right here. Now I've taken the liberty already of drawing this diagram out, but we have a golfer, and the golfer hits the ball so that it goes in a parabolic shape. It goes over a tree. A tree is 3 meters high. That's this right here. And it lands back on the ground at the same level. The tree itself was 14 meters away, so that's this right here. That's the horizontal distance to the tree. And what else are we told? Oh, that the whole distance of the ball's flight was 17.8 meters. So it starts here and it lands right there, and so 17.8 meters is the total horizontal distance that the ball travels. We're also told initially that when it lands, it's 2.24 seconds later. That means the whole flight of the ball was 2.24 seconds. And finally, we were told, well, actually, in part A, we're told that the angle that the ball left the club, right here, you would call that theta, is 54 degrees. So that's our knowns. That's what we're given so far for this this golf club problem. And the question for part A is, what was the initial speed? Okay, so this initial velocity right here is what we want to find out. We don't know that, so we're solving for that. We're solving for initial velocity or initial speed, not in the x or y direction, but in the direction that it's actually traveling. In this case, 54 degrees above the horizontal. So hopefully that gives you a little sense of what we're looking at here. And like I said, we want to know what that initial velocity is. I'm going to write, hopefully I'm going to start doing this more often. I'm going to start writing down our goals for this problem right here. In order to solve this, we've got two main goals that we want to achieve. Number one, we want to use the total time, which we're given, and the total horizontal displacement, which we're also given, to determine initial velocity in the x direction. All right. So that's I'm going to mark this up here a little bit. I'm going to turn my green back on. There we go. To find initial velocity in the x direction. So total time t and total horizontal displacement for the whole flight of the ball. Secondly, we're going to use initial velocity, which we just found up here, in conjunction with the angle theta, which we're told that's 54 degrees, to find the magnitude of the initial velocity. Okay, so two main steps that we're going to achieve, and that's hopefully going to give us our goal of solving for the initial velocity of the ball. So how do we go about doing this? Well, let's use total time t and total horizontal displacement to find the initial velocity in the x direction right here. So I'm going to switch back to my red, and I'm going to just write up here. So initial velocity in the x direction is the displacement in the x direction divided by the time in that direction. Now the time applies to both directions, remember, but that certainly applies to x. So let's write in what we know for our delta x. Our total trip is 17.8 meters. 17.8 meters, and the total time is 2.24 seconds. And the reason that we're doing this in the x direction and not in the y direction is because there's no acceleration in the x direction. So we have an even rate of motion in the horizontal direction. So we can take the whole distance and the amount of time, and that'll give us the initial velocity in the x direction. And that comes out to be 7.9 meters per second. 7.9 meters per second. That's our initial velocity in the x direction. So that, you might say, is Turn my green back on here. Is that right there? VI in the X direction. Okay, we're actually part way there. Well, we're almost all the way there. Why? Well, because if that is the component in the X direction, and we know what the angle is between the X direction and the actual initial velocity we're solving for, we can easily solve for that initial velocity. So, what is that? Well, we know that the initial velocity is the initial velocity in the X direction is initial velocity times a cosine of theta, right? And we've done that a number of times. You take your magnitude times the cosine of theta, and that gives you your component in the X direction. When we know the X direction component and we know theta, now we can simply solve for magnitude of just VI by taking our cosine of theta and dividing it, and taking it down to the denominator under initial velocity in the X direction. VI in the X direction divided by the cosine of theta. That will give us our magnitude of the initial velocity as it leaves the golfer's club. So we just calculated the initial velocity in the X direction. That's right here, 7.9 meters per second. And we're going to divide that by cosine of theta. And theta in this case is 54. 54 degrees. So 7.9 divided by the cosine of 54 is 13.4 meters per second. We actually don't need to calculate the direction because we're already given the direction right here, 54 degrees above the horizontal. So this is simply the magnitude of the initial velocity as it leaves the club. It's that velocity right there, leaving the club and being projected upwards at 54 degrees above the horizontal. And that's it for part A. So now let's look at part B.